All right, kids, we're going to introduce Chapter 9 through this short little video. And the way we're going to start this off is we're going to reintroduce you to some of the properties involving radicals. Now, what I have done in the past with these videos is I have encouraged students to go ahead and pause the video and then copy down the notes from Part 1 that you see up on the screen. And then after you have the notes copied, go ahead and restart the video so that you can listen to the presentation and see what's happening instead of trying to write down the notes and listen at the same time. So go ahead and take a minute and pause the video, copy down the notes from Part 1, and then we'll talk about them, and then we'll scroll the screen up and give you an opportunity to copy down the rest of the notes from the lesson. Now, many of you in Algebra 1 that have had Algebra 1 have done some extensive work with radicals. So we start with this definition. Let's let A and B be any positive real number. That would include decimals, fractions, and mixed numbers, and so on, even irrational numbers for that matter. But the basic rules for radicals are you cannot add two radicals unless the numbers inside the radical are the same. And so, for example, let's look at this a square root of a plus square root of b. For example, the square root of a not working. Okay, I think we found the problem here. For example, the square root of a, if I have the square root of 5 plus the square root of 11, that cannot be simplified. The numbers inside the radical are not the same. The numbers inside the radical, I'll just give this to you as an aside if you want to write this down. The numbers inside the radical are referred to as radicands. Those are the numbers inside the radical. They have to be identical in order for the radicals to be combined. Now, if you look at Roman numeral 2, the square root of a times the square root of b, that can be combined into one radical. So if we were to take the same two radicals, the square root of 5 and the square root of 11, and multiply them together, we could get the square root of 55. But the square root of 5 plus the square root of 11 cannot be simplified. Rule 3 states that when you have a radical written as a fraction, you can write it as two separate radicals, the radical of the numerator over the radical of the denominator. And so, for example, the square root of 11 over 5 can be rewritten separately. We do use this technique somewhat later in Chapter 9. And then the fourth rule for radicals for square roots is the square root of any number squared is itself. By definition, a square root is a number that when multiplied to itself gives you your original radicand. So, for example, the square root of 9 can be written as 3. Now, when you get into Algebra 2, we talk about the positive and negative values for radicals. We don't do that too much in geometry because in geometry, we're using square roots to find the lengths of sides of triangles and other polygons. And so because we're trying to find the length of something, and it can never be a negative value, a lot of geometry teachers will just refer to the square root of a number as being only the positive root of the number. When you get into Algebra 2, you'll get into the positive root and the negative root. And so that's our basic review for radicals. And again, I know most of you or all of you have had this in Algebra 1, some of you more extensively than others. And we also have some students that have taken Algebra 2 prior to geometry, and so they would be very, very adept at working with these. And so now we go into solving quadratic equations. Now, one way to solve a quadratic equation, of course, is by factoring. But there is another technique that you can use when you do not have an x term in the equation. When you have just a squared term and a constant, you can put the squared term on one side of the equation and put the constant on the other side of the equation and take the square root of both sides. So for this assignment tonight, we are going to stress both the positive and the negative value of the square root. When we get into actually finding missing lengths of sides of triangles and other polygons, we will encourage you to just take the positive answer. And so tonight's assignment, you're going to get problems like this. This is from page 369. This is example 5C. You'll see that you have x squared equals 169. When you take the square root of both sides, using rule 4 up above, the square root of x squared is simply x, and the square root of 69 can be either positive or negative 13. Going to work a couple more examples with you, and then go ahead and allow you to work the rest of the problems. Tonight we're going to be dealing with, on pages 368 and 369. We're going to have you do 1 through 8, but we're only doing the A, B, and C problems on 368 and 369, 1 through 8. So I'm going to do some of the C problems right now, and then you'll do the rest of them when you get into the assignment tonight. Starting with number 1. Okay, this is number 1C, the square root of 72. This is giving you just some practice at breaking down a radical. When we break down a radical, we try to find the largest square root factor of the number. And the largest square root that is a factor, the largest perfect square root that's a factor of 72 is 36. And so I'm going to write the square root of 36, and then you would multiply that by the square root of 2. And so now we look at the larger factor, which happens to be a perfect square root. The square root of 36 is 6. Now again, we could write plus and minus 6 if this was an equation. All we're doing is simplifying here, so we're just going to write it as 6 times the square root of 2. When we're solving equations, if we had x equals the square root of 62, we would write plus or minus 6 root 2. Number 2C wants us to simplify the square root of 3 squared plus 4 squared. Get that out of there. Well, we can perform the exponent work inside the radical, and the square root of 3 squared is 9. The square root of, 3 squared is 9, 4 squared is 16. So it's the square root of 9 plus 16, which is the square root of 25, which again, that's a perfect square number. That comes out as a 5. My stylus pen's going crazy. Okay, so that's number 1C and 2C. Do a couple more examples for you. 3C, we have the fraction 4 over the square root of 2. Now in Algebra 1, we learned that when we have a radical in the denominator, that's not desirable. We don't like irrational numbers in the denominator. And so you learn this technique called rationalizing the denominator. And basically what you do is you're going to multiply the square root of 2 times itself. But when you go back to your early days in the middle school, whatever you do to one part of a fraction, you do to the other. So if I'm going to multiply the denominator by root 2, I'm going to have to also multiply the numerator by root 2. And so now my numerator is 4 times the square root of 2. My denominator, the square root of 2 times the square root of 2, is the square root of 4, which is 2. And then you can simplify that further by canceling 2 and the 4. And you end up with final answer of 2 times the square root of 2. Number 4C will be the last example I give you today, and then you're going to go ahead and work these. You already have 5C over here on the screen to the left. Here's 4C. You have the square root of 12 plus the square root of 27. Rule 1 stated you cannot add two radicals together if the radicands are different. And so what you're going to have to do is break these radicals down and try to take out some perfect square root factors. Well, the square root of 12, I can rewrite it as the square root of 4 times the square root of 3. And the square root of 27, I can break that up into a square root factor of 9 times the square root of 3. And then what happens is the perfect square roots can come out of the radical and be written in the front. So the square root of 4 would come out as 2. So that's 2 root 3. The square root of 9 comes out as a 3. That's 3 root 3. And now that the radicands are the same, you can combine the radicals by adding the numbers in front of the radical. 2 root 3 plus 3 root 3 gives you a final answer of 5 root 3. And think of adding radicals together the same way we had variables. When you have two variables that you want to add together, you can't add them unless it's the identical variable. 2 times x plus 3 times x is 5 times x. The same is true with radicals. If they're both root 3, they can be combined. I hope that helps you out tonight. Again, you're doing 1 through 8, the ABCs. We've already done the first 5 C problems. If you have any questions, I'll be in early tomorrow. Have a good night, kids.